All right, here we go with lesson 10.4. We're talking about the perimeters and areas of similar figures. Let's just remind ourselves first of all what similar figures mean. Same shape, different size. All right? So, if the similarity ratio of two similar figures is A to B, we always write similarity ratios in fraction form, it's just easier to see. Okay? Then the ratio of their perimeters is A to B, which, just make a little note to yourself, is the same as the ratio of side lengths, okay, in polygons. Then the ratio of their areas is A squared over B squared, or A squared to B squared. The reason for that is when you take the area of a figure, you get a squared unit, you get a squared amount, you take it times itself, okay? So A squared over B squared for area, A over B for perimeter. All right, so here's our first example. Okay, the following triangles are similar. We want to find the ratio, larger to smaller, of their perimeters and of their areas. See if we can squeeze all those words in there. Don't want to zoom out too far because then you can't see. All right, so because we want to go larger to smaller, all we're going to do for perimeters is we're going to take corresponding side lengths. Now, make sure that when you're doing your ratios, you do corresponding sides. So make sure your triangles, just because they're not facing the same direction now, you have to make sure you get the right corresponding side. So let's start with 5. It's a nice even number, whole number, that is, okay? Now, the corresponding side to 5 should be what? It's not 6, it should be 4. Okay, so the ratio of perimeters is 5 to 4. And what do you think the ratio of areas is going to be? It should just be 5 squared over 4 squared, which then is equal to 25 over 16. Okay? So that's all we do on this one. We have our perimeter ratio and our area ratio. That is how the perimeters and areas of these two figures compare to each other. Okay? Because they are similar. Keep that in mind. All right, example 2. We want to find area using similar figures. Okay? So the ratio of the length of the corresponding sides of two regular octagons. Anytime we have a regular figure, they're going to be similar if they're the same shape, they have the same number of sides, okay? So the ratio of the length of the corresponding sides of two regular octagons is 8 to 3, okay? And the area of the larger octagon is 320 square feet. We want to find the area of the smaller octagon. What we're going to do for this one is we're going to set up a ratio, or a proportion, excuse me. So 8 over 3 is our first ratio that we have. Now, proportion is setting two ratios equal to each other. Okay? So this is the ratio of perimeters. We are actually working with area. Okay, so what is the perimeter of areas going to be in this one? Instead of an equal sign, I'm going to make that an arrow. It should be 64 over 9. Okay, so that's what we're going to use to set equal to, because the area of the larger one is on top, or is 320 feet. The larger one is in the numerator, so we're going to put that area in the numerator, and we're going to put it over x. We're going to say that x is equal to the area of the smaller octagon. Okay, now we just want to solve for x. So how do you solve a proportion? Cross multiply and divide. So we are going to have 64x is equal to 320 times 9. 64x is going to be equal to 2,880. Okay, divide by 64. X is then going to equal 45 square feet. That is the area of the smaller octagon. So we set up a proportion. When you set up your proportion, make sure that you have area or perimeter, okay, depending on which one the problem is asking you for. That's very important to keep in mind. All right, so let's go ahead and flip to the back page then. Okay. Now, Benita has gardens. So she plants the same crop in 2 rectangular fields or gardens. She has big gardens. All right, so each dimension of the larger field, let me zoom out so you can actually see this here. There we go. I don't know if you can read it now. Hopefully you can, squint a little bit. All right, Benita plants the same crop in 2 rectangular fields. Each dimension of the larger field is 3.5 times the dimension of the smaller field. So to me, that means that if I have one rectangular field, and I say that this is 1, then this must be 3 point... No, that's not right. I have 2 rectangular fields. And if this is 1, that means this must be 3.5 times this dimension. So this must be 3.5. We'll see if I can make it through the rest of this problem without making another mistake. All right. So our ratio then of side lengths is going to be 1 to 3.5. 3.5 to 1 would also work, either one. Okay? Now, seeding the smaller field costs $8. How much money does seeding the larger field cost? Here's what we want to do. When we are talking about seeding a field, do you seed around the edges of the field or do you seed in the middle of the field? Hopefully, if you're actually going to get anything out of your crop, you seed in the middle of your field. Okay, so that's going to be area. So this is perimeter right here. Okay, so what do you think our area ratio is going to be? It's going to be 1 squared over 3.5 squared. Which is going to be equal to 1 to 12.25. Okay, so there's our area ratio of areas from the smaller field to the bigger field. So now, seeding the smaller field costs $8. How much money does seeding the larger field cost? Okay, well, let's just set it up in a proportion. 1 over 12.25 is going to be equal to, the smaller field is in the numerator, so 8 over x. All right, we'll just cross multiply and divide. Let's make sure we know that x equals the cost of seeding the larger field doing this a little bit backwards, you should probably define your variable before you put it in the proportion. All right? So now we cross multiply. X is going to be equal to 8 times 12.25. So X is actually going to be equal to $98. So it costs $8 to seed the smaller field and $98 to seed the larger field. All right, hope everybody has a great day. Have fun on your homework. And don't stay up too late watching this video, by the way.